Hello and welcome. Thank you so much for joining us. This is That Tech Show, the show that reveals the magicians behind the magic that is everyday technology. This week's episode, we have Audun Fauchald Strand, who is a principal engineer at NAV, the Norwegian Labour and Welfare Administration, which handles a third of the state budget of Norway. That is huge. Audun was introduced to us by Fred George, the grandfather of microservices. If you haven't checked that episode out, then please do so. It's an awesome episode. The two met a few years back after one of Fred's talks and then worked alongside one another whilst delivering the most extreme of digital transformation at NAV. Under Audun's leadership, NAV have moved the mainframes and an entirely external staff to a microservices architecture and a team of a few hundred that roll out releases a ridiculous number of times per day. This is probably the most inspirational transformations we've ever heard of, and it's in the public sector. How cool is that? Before all that, just a few housekeeping things. If you could please leave us a review on either Podchaser or Apple, that would be fantastic. It really helps spread the word of the channel. And if you want to support the channel even further, then please head on over to patreon.com/thattechshow, where you can support the channel for as little as £5 a month. So without further ado, here is Audun Fauchald Strand.
My name is Audun Fauchald Strand. I'm Norwegian, of course. I think I've worked in software for like 20 years now. I used to be a consultant, multiple places. My standard joke is twice a consultancy company has sent me to the company I work for now. But it was so bad that I quit the consultancy company both times. And then I started working for Finn, which is the biggest website in Norway. And they have like proper agile, proper development culture and everything. And that's where I learned a lot of what I think is smart now. And then I worked there for 4 years. And then I started working for NAV, which is the biggest government agency in Norway, and kind of been a part of a big transformation there for the last 4 years.
So let's just talk about the scale as well, because obviously we had a little catch up before the call. So, you know, give me a little bit of an interpretation, or give the listeners an interpretation of how big we're talking in terms of where you are now. Yeah,
well, NAV is basically one politician in 2006 or something said we need to merge a few different agencies in Norway. So they basically merge everything to do with health and everything to do with work into one big agency. And I haven't studied this in detail, but apparently we do the same as like 20, 30 different agencies in the US. So we basically handle everything for the welfare state and pensions. So we pay out about a third of the national budget in Norway is paid out through us. And we handle everything from parental benefits to sickness benefits to pensions to getting people jobs and everything. So it's basically a one-stop shop for most of the stuff, except for the tax part. The tax part is a separate thing, so we don't take money, we just pay out money and help people.
Which is nice. It's sort of like the Robin Hood side, just giving all the money away. So in terms of the total amount, then it's a third of the budget. What sort of figure is that you're paying?
I think it's about, and I'm struggling a bit with the English American thing, 400 billion Norwegian kroner, about 40 billion pounds then probably.
Wow. So 40 billion pounds. I don't know how much that is in dollars. People, American listeners can do the conversion. It's a bit of it's an activity podcast for you. Go and look that up. Which is quite an incredible amount, isn't it? Really, it's a huge amount. And also when we were talking about the total number of users you have, which is the entirety of Norway.
Yeah, well, at least in theory, I think all Norwegians get some money from now, because you get, or your parents at least get when you're a child, and then you have when you get a kid, or when you get sick, or when you lose a job, or the last thing you can, if you don't have the money, we can pay for your funeral. So there's this saying, we support you from all the way from you're born till you die, basically. And then of course the pension part is for everybody gets a pension. So we have a relationship with every Norwegian, basically. And we also say we it's not important for us to get more customers because we have the Norway's population, and we only have organic growth. Yeah, we only have organic growth in our user base with kind of a 9-month warning when you get new users.
Your organic growth is literally organic growth, isn't it? Really, yeah. Actually growing new humans. So that's that. I mean, it's pretty incredible, really, that you are serving the entirety of the country, and the amount that you're dealing with in terms of how much you've got to pay out. So obviously, we've talked about this very briefly, that our introduction came via Fred George, who was a guest on the show recently, and as you mentioned just before, a big name in tech. So you've gone through a massive transformation in recent years. So talk us through where that started and where you've got to now. Yeah.
Well, first of all, we can say that NAV is, even though we were kind of a merge in 2006, the things that were merged are much older. So our older system is it's about exactly my age. It's 42 years old. It's a big mainframe handling all the sickness benefits. And then after 2006, we had this strategic decision of not having any developers. We only had architects and project managers and testers and everything, but no developers. That was done by consultancies. But we got a new CIO in 2016, I think. And he said, well, we need to own our technical future, basically. So he always said, you need to be smart to buy smart. So he basically said, we need to hire developers. So we started that in 2016. I was number 8 or something. Well, this sounds like a startup, but this is in the middle of a 20,000 people big organization and an IT department of several hundreds, even though they didn't have developers. But
it's quite incredible as well to think about the fact that this is happening, this scale up from 0 developers, or 0 permanent developers at the very least. This is happening in the midst of the captive audience that we've previously spoken about, and the amount of money that's getting paid out. This transformation, whilst maintaining that stability, is incredible.
It's a big challenge, and there really isn't an option to not work.
Absolutely. I mean, if your system starts to fail, then the whole country has problems.
So now we're about 200 developers, 300, I think, if you count data engineers as developers, and sometimes we do. And we are still trying to grow further, because even though we have this many internal developers, we still have a few hundred consultants as well, and we don't want to get rid of all consultants, but there's still room for more developers. But it's hiring people isn't necessarily the easiest thing in the world, because we also want to keep kind of the quality of who we hire.
No, absolutely. So, I mean, how do you get through that process then? So, I mean, you talked about you met Fred in 2015. We talked about this just as we were setting up the podcast, but talk to us about how that came about.
Oh yeah, I met Fred in 2015, I think, because I wanted to go to me and a few friends, we wanted to go to a great restaurant, and we found Noma in Copenhagen. So we needed to find a software conference that made it possible for us to also eat at Noma. So we went to Copenhagen, and we had the Fred George's incredible microservice workshop. Another funny detail is we actually had Eric Evans, the author of the domain-driven design book. He was one of the participants in the workshop. So it was really cool. And after that, we got. I had Fred to do that workshop for Finn, the other company I worked for at the time, and then later we had him at NAV as well, because the workshop is really great at teaching asynchronous programming, basically, on microservices. And then we had that a few times, and then Fred all of a sudden sent an email saying, "Can I come and work for you?" So we said, "Yes, of course." And he moved from Las Vegas to Oslo, and he went straight into the biggest product we we were developing at the time, the one for replacing the sickness benefit, the big mainframe. And so basically we started doing that, and after a while, the team went all in on kind of the rapids and rivers thing that Fred has developed, I think, with basically having when you first hear about that kind of architecture, it's quite strange, or it sounds strange, because you basically have this big Kafka or other message queue in the middle, and all of the microservices send everything as a message on Kafka, and then you kind of have the other microservices listening to the rapid and filtering out and only caring about a few of the messages, and that filter is kind of the rivers. And then when they do something, they send it back to the rapid. So we basically have this loop of messages just going through and through, and you just add new microservices on, and you can just you read new messages. So kind of a big view of that. We have the applications coming into the rapid, and we do a lot of processing, and then we have the decisions, if people get money or how much money and stuff coming out. And then I think that Kafka topic is like multiple terabytes, because there's so much data coming in, and every little step adds a new message to the rapid topic.
So was the plan with this replacement of that mainframe that is the same age as you, was the plan always to go with microservices, following on from meeting with Fred, or was it really Fred's joining you at the company that spurred you to go in that direction?
Well, I would say the microservice part was quite given. I think we worked for like half a year before he came in as well, and doing a big monolith wasn't really on the card at any time. But actually, one of the biggest application in this application suite isn't, at least not a Fred style microservice. It's the one trying to kind of model the law part of it, saying what your rights are. And that's several thousand lines of code. So that's not a typical microservice, but it's kind of, and I can never get my words right. It's either the most complicated part of the complex and complicated quadrant.
Yeah.
And this isn't that. The law is basically implementing what's in the book. So it's kind of a known state. And then you need less of the flexibility that the small microservices give you, and you need more of the stable parts of having a bigger thing where you can have objects in the same address space.
Yeah, because I think when we talked to Fred, we did talk about the when to not use microservices, because I know some of his more recent talks are when to not use microservices. And actually, if it is a known entity and you're not trying to figure things out, then that is a time to not use microservices. So it sounds like what you've actually ended up with there is a blend between the stuff that is a little bit more unknown and has to happen, very, very quickly, lots of computation, versus the actual, okay, this is the implementation of the law, and that's not going to change. So there's no real reason to have microservices there, because the idea of microservices, I suppose, is that they have quite a short half-life, I suppose, don't they? They get changed quite quickly and quite frequently as you improve and modify them. So I guess in that instance, the law isn't moving that fast to necessitate that being microservices.
No, but then, for instance, we have smaller components that do like replay of the applications onto the topic to do statistics and stuff, and then you make smaller components do that. But the bigger part, the more complicated stuff, it goes into the bigger application.
So in one of our earlier talks, we've had conversation with some of the people who've been involved in the UK government in NHS test and trace, for example, and obviously we're all coming out of having a crazy year and a bit, I suppose, of pandemic world, and our government was not necessarily known for being that forward thinking in terms of its transitions to more modern technology. But how did you manage to get the buy-in for introducing microservices in the government?
It feels like we didn't. this sounds absurd. We just did it, basically.
So ask forgiveness rather than permission.
Yeah, and also it was, well, we had, actually there was one discussion early on in this specific whether we wanted to reuse a bigger component from an earlier project or not, but we find that, at least my experience, that's something that seems similar when you created one part and you want to go to the second part. It feels like the second part is going to be similar to the first, but when you dive into the details, it's almost never the case that it's as useful as you think to reuse stuff. And we also think that having the ownership and the domain knowledge and the knowledge of the code is more important, because that's going to serve you for a longer time than some kind of initial boost you get just by reusing something from the start. You need to, because these are systems, we're not in a competitive situation. This is software that's going to, or at least an organization that's going to handle a problem for 40 more years. So there's being quicker to the first, quicker in the first 3 months is not as important as actually having the ability to change the system in 10 years' time. And then you need to, it's more important to build a team and an organization that knows their code base.
So how bought in is the organization, the government? How bought in is the government in the idea that this is, now product development and this is going to be continuously developed?
Well, it's getting there. We are still kind of, because we have these big modernization programs, and that means we need to ask for extra money from the finance department. And their processes for giving out extra money is the same whether we want to build software or a bridge. And of course, building a software and building a bridge isn't the same. So when you go into how you want to run a big chunk of work building software, you need to think about it differently. You need to, for instance, you need to have much more focus on learning, I think, and trying to see progress in software development can be measured in different ways than if you build a bridge. You can say, we build something that we're not going to reuse anymore, but we learned a lot, so it's still progress. And trying to get that into the process, because the people who gives us money, they want to have some kind of checks along the way if you are spending the money wisely. And it's not easy, I think, to explain to someone who's not experienced in software how you can actually have progress while still throwing away all the code you just written. And it still feels like progress, because when you learned it, rewriting everything isn't the problem when you know the domain.
Well, how far through are you in this transformation? Have you still got any of that mainframe left?
Yes, we are kind of. Also, we have multiple mainframes. At least for some definition of mainframe. we are more than halfway through, I think, the big mainframe, and then the next big thing we're going to do is this incredibly strange Oracle architecture thing. This is only 20 years old, but it was made just before J2E happened, so nobody knew how to do application servers, and IBM had WebServer. And Oracle had this thing, which I can't really remember what they called anymore, where you put everything, and literally everything, inside the database. So it sounds like stored procedures, but it's not really stored procedures. It's like Java running inside the Oracle database, and every instance of a Java object has their cell in a table in an Oracle database. And
the opposite of distributed computing.
Yeah, and the developers for to do local development, you have to have an instance of an Oracle database. Wow. And it's never funny to have an instance of an Oracle database in a laptop.
No, I can't imagine that's going to be particularly efficient.
No, and they have this kind of front-end tool as well called SQL Forms, I think.
Everybody loves SQL Forms.
It's actually the funniest thing about that system is the front end. They have this development mode where there's a frame around the GUI, which is used only for development, and this is disabled in production. But that means they can't change the size of the window in production, because that breaks the disabling of the debug information. And this system is so old; it's built for 600 times 480 screens.
Yeah, well, this is the sort of system that you're used to seeing in banks and insurance companies. When you finally get the chance to peek over the shoulder of someone who's operating one of those windows, and it's all squashed up into a corner. And
that's the thing.
It's
because
exactly
the
that.
GUI
Isn't
is
it?
like its own icons. It's like one man heading that direction means do something, and face heading means something else. So it's basically impossible to see because it's a small window in the corner of your screen with only icons. So they have to use like magnifying glasses to use the system sometimes. So that's the next one we're going to do something about, or we've just started now.
I like that you said that this is only 20 years old, which is probably older than some of our listeners. Or I know it's older than some of our listeners because we have statistics, guys.
Well, we actually have even older systems, or we had, but they're kind of out now. We had one database of old earning information because you need that to calculate pensions. And can't remember the specific details, but you need kind of the earning information of the spouses of people until everybody's dead, basically. So, but this database is now in a read-only mode, and we basically took this strange file and put some Java on top, so it's easier to run. We can actually run that in Docker and Kubernetes, but the actual file is like 40, 50, 60 years old, or 45 years old or something.
So that's sort of a case of archiving it then, rather than actually migrating it.
Yeah, well, basically we took the data and put some more modern stuff around it, but the data is still there because we can't remove the data. We need the data.
But there's no plan really to migrate that into your current system? No, just sort of...
No, there doesn't feel like there's a need for that because we have an okay way of getting that data out. So
before you started on this transformation, I mean, I presume there probably wasn't very much change that had happened really within the system over the previous years. I mean, how frequently were you changing this? How frequently were you doing releases?
Well, we had up until 2016, I think, or 14, we had something like 4 releases a year.
Wow. Okay.
And then we kind of had this ongoing improvement. Actually, the talk we're having at DevOps Enterprise is called From 4 Releases a Year to Once Every Other Minute. Because right in 2021, we are doing 1,350 approximately the releases a week. And if
a week? Wow.
And if you put the normal Norwegian work week into that, you can kind of get that into once every other minute. And that sounds even funnier than 1,300 a week. But right now we have something like 1,200 applications and that amount of deployments. But we still have some deployments stands for a much bigger share. No, some applications stand for a much bigger share of deployments than others, of course.
So near as damn it, 1,400 deployments a week. That's incredible. How big are those? How big are those deployments? What's in a deployment?
Well, it's no easy answer to that question. Some of them are basically just bumping. If Snyk tells us you need to bump libraries, that's one deployment, and sometimes it's much bigger. So it's everything from smaller to bigger. Actually, it's one of the funniest things. We have this. Basically, it's a recruitment portal for now, but on the bottom part of that webpage, there's like this aggregated view of all the commits we're doing on our GitHub organization, because most of us, at least, or not most, most of our stuff is open source. So just watching all the commits coming through, and you see something is like adding this field to this form or changing this rule, and something is just bumping dependencies or doing everything else, or probably also there's a bit of people deploying to see if their deployment pipeline works now.
But that's a tiny releases then, essentially.
Yeah.
So is this all? How's this all wrapped up then? Is this wrapped up in a continuous delivery model? How have you got from 4 release? I mean, we're eating into your talk a little bit, so we don't want to.
That's no problem.
We want people to go to your talk and listen to your talk as well. But give us a flavour. How do you get from 4 releases to 1,400 a week? Actually, 4 releases a year to 1,400 a week. How many is that a year? Have you added that up?
No, well, 70.
Big Sam, bring a calculator up.
Times it by 52.
Yeah.
1,400 times 52.
Well, not 52 because we have Norway is good on vacations. So we have like nothing in the summer, and then we have Easter and we have winter vacation and Christmas. So there's like maybe 40 weeks or something.
40 weeks. Yeah. Oh, we should all move to Norway.
Yeah. But back to your question, it's like there's a big technical part, of course. We built this application platform called Nice, which is what I consider kind of the normal thing now with Kubernetes and normal cloud native foundation kind of architecture with Prometheus and everything. And that takes a lot of the difficulty out of doing kind of the technical releases. You can deploy without having downtime, so you can basically deploy during daytime, and that makes it safer. And then we have gone through almost all deployment pipeline software known to man. We started with Jenkins's running on Linux virtual machines locally, and then we had this Travis period, and then the Travis thing happened, and then we had this Circle CI period, and then GitHub Action came about. And because we use GitHub for storing the code, it's easier to basically token-wise, it's much easier to get the security set up when you have the code stored in GitHub and to use GitHub Actions. So the Nice platform has this home-built action, and you basically just use that and you paste some tokens into your repo, and then you have this deployment descriptor that you send into the cluster, and then everything happens by magic after that. And so kind of the deployment pipeline has become really good right now. I would say it's I really like GitHub Actions. It feels like the perfect kind of abstraction and for reuse and making deployments.
So how do you actually manage, if you've got all these microservices and they're all in all sort of Kubernetes deployments, how are you actually managing the sort of coordination of all of those Kubernetes containers then? Because, some of that can be relatively complex. The last time I was working some of that out, we used Terraform to be able to control and give us an indication of state management, because we were really struggling at the time of not knowing which version of a given application was actually running in Kubernetes. Have you figured something out with that, or are you just deploying that many things that quickly that it doesn't really matter?
Well, first of all, we kind of want to split it up so our goal is for no one to need to have the kind of the overview of everything. You should know your team stuff. So the strongest concept in all our platforms is basically the team. The team has their own applications and it's into their namespace, and you don't need to consider everything but your team stuff. And we only use Terraform for like infrastructure stuff, like setting up the cluster. And other than that, we have this simplified deployment descriptor, basically giving you some choices in how you want to set up this in Kubernetes, but we're taking a lot of the choices away from you, so we don't need to consider how to do load balancing or anything. That's just done. And then we have the pattern we've gone for is we basically have several or multiple operators in the cluster. So if you want alerts, for instance, you put out a different YAML file saying what Prometheus query language statements you want alerts on, and that's sent into the cluster, and you have a piece of software that we've written that transforms that into and puts it into Prometheus Alert Manager, and then you get alerts in the configured Slack channel or on SMS. So we try to use as much as possible to have building the infrastructure as well as software, because it's easier to test and maintain Go code than Terraform code when you need to do somewhat complex stuff.
So it sounds like the control then is largely around namespaces then. So if each of the teams manages their own namespace, then that's relatively straightforward. They can look after that, the control of that.
And when we move to the cloud, we also have like when you register your team, you get a namespace in the cluster, and you get a separate project in GCP. And then, so if you, for instance, when you say you want a database, you get a database in your own project. And then we use some Google magic to kind of have a secure connection between the app in the cluster and the database in the project.
Okay, cool. And how does that work with testing as well? Then, do you have any? I mean, what levels of testing have you implemented in that?
Well, we try to focus a lot on testing. There's this incredible article on martinfowler.com, not written by him, but someone else, about microservice testing strategies, which kind of says you need to test your own thing in isolation, because when everything moves at different speeds, you can't really depend on a shared shared environment, because even though you have like your dependencies are in the cluster, you don't know if the same version of your dependency are in test and in production. So basically, you need to test your code in isolation and rather have good monitoring and stuff to make sure that you pick up if something happens in production. But I would say we try to have kind of a normal test pyramid with loads of unit tests and some integration end-to-end test. And basically the top level is the component test, which is what you're going to deploy, and then you mock out the dependencies instead of, at least we aim for that, to mock out your dependencies instead of depending on someone else's code in a shared test environment.
So do you do any sort of integration testing then, where it's a shared environment, or are you purely sort of relying on those sort of mocks? I mean, because there's so much to coordinate here there.
Yeah, mostly mocks, but a pattern in that article I mentioned that we try to do is kind of have some other tests that basically test your assumptions about the dependencies. So if you depend on a service, instead of having your code or your app depending on that in test, you create a separate test that calls the code you want to depend on and see if that behaves as you think. Right. Then you kind of you isolated your assumptions about the other code into a separate test. And then you can also do stuff like consumer-driven contracts, which is where you can have your test running in the other person's repository about what you need from that code. So there's loads of techniques I think you can use without actually having a shared test environment.
Yeah, that's really interesting. Is that something? Is that how did you come to that sort of conclusion? How did you develop that?
Well, I think it kind of came over time, because we saw the same at Finn. We started with multiple test environments, but when you have that many applications and you still have some dependencies, you see that the shared test environment with everything, it takes so much time to coordinate having a shared test environment that actually works. Yeah. And basically it's more work than it's gain. so you realize you have to do you have to test it in other ways. And at least if you can isolate your team stuff, so you test everything, you have a test environment for your team's applications, and then you mock out the stuff from the other teams. That's a big help, because at least at Finn, we had this rule that you can't complain about other people's applications in a test environment just not being stable, because it's a test environment, and you can't really expect them to be stable because that's production. So then maybe you should try to, for instance, use feature toggling or something to get your code into production and see if it works there instead, if it's important.
Yeah, so speaking about the production side of things, do you do any sort of coordinated load testing? And if so, what sort of environment would that be against?
No, we have very little load testing, but load really isn't a big problem for us. At least I am a bit... when I worked for Finn, we had which is of course Norway's biggest website, we had loads of traffic, and NAV doesn't really have that much traffic. So the traffic part isn't as important. We have some, I think some teams do some local load testing, particularly when they've made new apps and stuff, but it's nothing big coordinated on the load side.
What sort of traffic were you talking with Finn?
I'm not sure I have the numbers in my head, but it's nothing even close to at Finn we had several hundred page views a day, several 100 million page views a day, and there's nothing close up now. I should have the numbers in my head, but I don't.
Well, we weren't necessarily going to talk about Finn that much, were we? So you're excused for not having the numbers to hand. But in that environment, was that something where you did have to prepare for load tests? And if so, yes. How did you deal with did you, obviously your thinking has evolved over time, but I think there's still a certain small pocket within our industry which wants to have a scaled test environment. I'm curious as to what your thoughts are on that, based on the journey you've gone through. Well,
the problem we find it's incredibly difficult to get the proper load test on a big environment, I think, because you basically need to replicate your production environment completely, and you need to have the data set up in the correct way as well.
Yeah.
And I've never really seen that really work. I've done, like I said before, I've done some smaller load tests, I think, on a few applications. But then I have to admit, I haven't really seen a big value of that either, because, well, of course, it's difficult. They've still broken in production sometimes because of load, because it's really difficult to understand how to load test. And if you can move fast, it's often easier to either roll back or try some kind of staggered release so you can see if it works, instead of trying to make sure everything works before you release.
And so where you're at now then, I mean, we talked a bit, or you mentioned briefly about Prometheus. So presumably you've then shifted your focus to making sure that you've got really good monitoring and alerting. It's instead, so that presumably, and I suppose if you can release as fast as you can release, that gives you a probably quite a reactive way of dealing with any issues as they arise. Yeah,
and of course there's multiple strategies based on what kind of systems you have. If you have kind of the big logic applications where if you have an error, people either get the wrong amount of money or no money, you have to have more tests. But on kind of, we focus a lot on making the systems able to handle errors and also do really good observability on them. The Nice platform has this kind of default Grafana dashboard you get from Prometheus, because the interconnection between Prometheus and Kubernetes is really good. So it's easy to set up kind of a standard dashboard that shows all the normal things. And if you use the correct Java tools, you can get loads of Java or Kotlin, or at least JVM metrics as well, into your dashboard really easily. So, and just having that as a starting point makes it easier for the teams to see how they can build better monitoring after they've seen kind of what you get for free. And then, of course, the goal is to make you kind of raise the abstraction layer on the monitoring. So you after a while, they start to more do business level monitoring. And not instead of the infrastructure part, but as a complement. And that's a much better way to see if it actually works, because of the dynamicy of a Kubernetes environment. It's difficult to say if something works or not based on infrastructure, because it's kind of self-healing in a way as well.
Yeah, of course. And in terms of like the number of bugs and actual issues that you have, is that a high count that you're dealing with? Is it a low count?
What do you mean issues?
Well, I mean, well, that probably answers my question actually. But in terms of the number of bugs that you have with this amount of deployments, I mean, are you seeing a high count of them? Are you seeing a low count? You know, how many do you have to react to?
Well, we don't really have an aggregated view of that. That's one of the things we're really inspired by the Accelerate book, and we would love to have kind of the 4 key metrics from Accelerate, but and we do deployment frequency, and we're just about to release measurements for lead time. But the difficult part is the one that actually has to do with errors, because it's much harder, at least I find it's much harder to do a uniform way of detecting errors in your application. So it's, if you want to measure mean time to recovery, you have to kind of see when does the error occur, and we haven't found a good way of doing that uniformly for applications. So we don't really have a really good number for like bugs, for instance, not on an aggregated level.
So that's the next step, is it then?
Yeah, we hope so. We just need to figure out a good way of doing it.
Interesting. So, I mean, one of the things that I want to go back to a little bit here is, you've gone from 0 developers to 2 to 300, depending on which developers you're counting. How do you go about finding developers for an organization that's never had any, or never had any permanent ones? I mean, how do you talk to me about, like, how do you find the right developers? How do you find the first one? How do you find to get the quality up there?
Well, I would say there's kind of two different ways. We had to basically invent the process of interviewing developers, and we've gone for something which I think is. I always thought that kind of the at least for the big tech companies, the way they do it with kind of an algorithmic based smaller code task isn't really that. It doesn't really tell you too much about how that person would work in a normal environment. First of all, because most of the task you're given doesn't match what you're doing. It's not like put these four tables from a database up on a web page, which is like 80% of what everybody does. So we do a code task, but the developers can do it at home. And it's basically more of an object-oriented modeling thing than kind of a complicated problem to solve. And of course, the most important part of that thing is the discussion we have afterwards. So we focus a lot on talking about the choices you've done and why you've chosen these objects and not these, and why you model it like that. And then the other part, how to get the people in, is we had this one big advantage. First of all, because now we're so big and we had so many consultants over time, everybody knew about NAV. And to be frank, most people knew that working at NAV as a software developer was quite bad.
Yeah. So how did you convince them otherwise then? How did you change that sort of that sort of view that people might have in the
Our big advantage then was because everybody knew how bad it was. Just going out and saying normal things made them understand how much better it became. And then when we actually did some properly good stuff like the application platform, which is really good, it's even a bigger surprise. But just saying we want to reduce projects and focus on products and hire on developers, that was almost enough to get the word spread. But of course, being a public company, wages is always a problem. We can't pay as much as the people we hire as consultants, which is always difficult. But on the other hand, it means that we have this thing. We say that people that work for NAV, they choose to work for NAV almost every week, because the software, if you're on LinkedIn, you get calls every week. And so you basically have to say, well, no, I'm not. I'm still happy where I am. And that makes for a really enthusiastic and motivated workforce. They've chosen to work for NAV, and they want to work for something that's a good cause, and not work for people they don't know becoming richer.
So are all of your developers from Norway? Are they all Norwegian, or do you have people from around the world?
No, they're all Norwegian. I'm not sure if we can. Well, they're not all from Norway, but they all live in Norway.
Okay. So you do recruit globally then?
Well, we had Fred at least. We never we never had ads outside Norway, but the people that moved into Norway that work for us, and we want. Because, for instance, all the laws are in Norwegian, mastering the language is important. And our code is kind of a mix of English and Norwegian, which is really strange, but it has to be that way because you can't translate some of the structure of the municipalities and stuff in Norway. You can't translate that into English. Then you go into the English society model. So then you have, if you use English, you have to have this list of what the words actually mean in Norwegian, and then you can just as well put Norwegian words straight into the code. But it took me at least a year to get used to writing Norwegian words in the code.
So that's interesting. Let's. I want to know a little bit more about that. So Norwegian words in the code. What extent are we talking here? Are we talking variables and comments, or how far does it go?
Yeah, variables and class names, and well, everything that kind of comes from the domain. And we have this discussion regularly, because everybody, when there's new people coming in, they think, well, you can't put Norwegian word in the code, but then they realize when they're into it that you have really no choice, even though it feels strange.
Because I was talking to some guys just this morning, who were one Polish, one Ukrainian, and we were talking about how most code is written in English, globally, and I think that's probably because all of the syntax is English. So when you're talking about Norwegian in the code, you're still talking about a vast percentage of that code is going to read like English because it's Java or Kotlin or whatever it is. And
the strangest part is when at least in normal Java code, you have all these patterns. Like when you have a factory, do you say factory, or do you use the Norwegian word for factory when you're referring to the factory pattern or the builder? And we tend to have used English words for that. So we have like a Norwegian word builder. So you have mixed languages inside the same class names, which is even stranger. And you really have to get used to it to read it and understand it right away.
Are there kind of internal rules then that you've all kind of agreed to that suggest like, okay, these types of things we're going to write in Norwegian and we're going to leave this stuff in English? Or is it just
not global rules, but like team rules at least? But we're too big to have like global rules. For instance, the application platform is pure English because there's no Norwegian domain when it comes to deployments and stuff like that. So then we've had there's always someone who wants to have like these global rules, and they try and then it doesn't work.
Yeah. And I was going to say as well, because I'm right in understanding that actually this a lot of this code is probably legacy code from consultants, different consultants coming in. So maybe there's a lot to refactor there in terms of, okay, what do these different consultancies, how have they written code versus how do we want to write code, and then how do well, yeah, I mean, it just sounds like a lot to...
One of the strange smells we have in the code is sometimes you see like imports with consultancy company names in them.
And libraries and things.
Yeah, and it probably made sense at the time, but it feels strange when they want to insource to kind of be based on libraries from the consultancy companies which aren't there anymore, or at least not in the same capacity or position.
What was so hard around... what is so hard, around trying to align things globally, whether you use English or Norwegian, even simple patterns or whatever? Have you attempted that, and what's been so hard to make it not work?
I think we value the autonomy of the team because of the size. We have like 100 teams, and we really think that the best ways for a team to create a good solution for a problem is if they have like not just developers, but you have all the different disciplines into the team. And when you manage to describe a problem and for themselves to design the solution, that's when you get the good teams and the good solutions. So, but at the same time, we have this, as you say, there's a value in alignment as well. So even though not necessarily on all the levels you can think about it, I don't really care that everybody chooses the same programming language. That's something that should be a team decision, I think. But we also have, so we have basically two things that to handle the alignment. We have internal tech radar, and we kind of say that the rule is everything is allowed as long as you publish it. So you can basically take whatever decisions you want technically, but you have to put it in the tech radar because then people will see it, and if they think it's a bad decision, it's their responsibility to say so. And maybe they've tried this thing before or something. And we also have me and one other guy. We're kind of the principal engineers with a fancy title, and we have this presentation. We go around talking to the teams about what we think are good patterns or good directions we want the team to go to. But it's really important for us to say, this is our opinion. We know NAV is really heterogeneous. We can't really say everybody should do this. We can say this is a good direction to go in, and then we can have a discussion with the team if that's appropriate or smart for them to do. But it's really interesting to balance the alignment and the autonomy. It's incredibly difficult, but also kind of fun.
I think there's flavors of that you see in the likes of Netflix and Spotify as well, because obviously Spotify talk about that in their model, don't they, with the high alignment side of things. And then Netflix have that same principle of context versus control, where there are some standard protocols that are supposedly followed within Netflix, but they will allow you to go out as an engineer and pick a new language, pick a new tool, and bring it back in and introduce that back to the organization. So it's a similar method that you guys have adopted then.
Yeah, I think, and it's probably easiest to describe it in terms of the application platform where I think Spotify also called it the golden path. So instead of saying everybody should do this, you just make it easy to do it one way.
Yeah.
And then you say to the teams, you can choose to do whatever, but if you do it like this, it's easy. If you go the other way, you have to do everything yourself.
And so when you actually started on this journey, how did you go about, you're going from real legacy stuff. How did you go about choosing the languages you would start working within? Because obviously you've allowed that to drift over time, but how did you pick where you were going to start?
Well, I'm not sure if this is a Norwegian thing or kind of a global thing, but in Norway, most companies are kind of divided into the JVM or .NET.
I think that's a global thing, from what I've seen.
we're basically in the JVM camp.
Right.
We had, up until 2016, almost everything except for the mainframe Oracle things was Java. And then we basically had what you described. We had some people that was really interested in Kotlin. And they tried it on smaller parts of the systems, and it kind of grew organically. So I would say now we write mostly Kotlin, but we still have mostly Java.
You didn't have any bursts of Scala for a while, because that was very popular for a brief period of time.
Scala is kind of the only thing everybody agrees on. We don't want to. We can have good discussions. There's two things I can say on internal Slack that will always start discussions. That's either Spring or not Spring,
right?
And Maven versus Grady. And we can, we basically, that's where we're giving up on alignment. People just choose. So
which side does the whole organization tend to fall on in terms of Spring or not Spring, or Gradle versus Maven?
I think
out of curiosity, this
Spring thing is that's kind of even 50-50, I think. Probably the more Kotlin friendly you are, the less Spring friendly you are, but there are teams doing Spring and Kotlin together.
Yeah.
And on the Maven Gradle thing, I think it's very evenly matched there. So I'm proudly in the Gradle camp.
Yeah. And where do you sit on the Spring fence?
I'm outside the Spring.
Oh, okay. So you're outside of the Spring camp.
Yeah. But I actually think it's not my decision to make for teams what to do, because it depends on what they know and what they want to use, I think. And I used to be a Java developer, and I've never had an as easy translation into new language as I had to Kotlin. Java to Kotlin is a really easy transition. I've written some Go and some Python lately, and that's a bigger step than going from Java to Kotlin. Well, if you have Java code on your clipboard, you can just paste it into IntelliJ and it kind of translates it into Kotlin. So it can't be easier than that.
Yeah, I'm starting to get the impression, because I've been doing a bit of Kotlin development recently as well, and I'm starting to get the impression that you need to have IntelliJ to do it properly. Yeah. Because I'm banging my head against a brick wall trying to do it in VS Code.
Yeah, you probably... Well, they're the ones who created the language, so it's probably easiest to do.
Exactly. Yeah. It seems like that. Like every time I'm going through some of these tutorials and I hit the things where it's like, and now you just do this little thing, IntelliJ. I'm like, well, okay, how do I do it?
but I still find when I write Kotlin that I think I've written good Kotlin, and then I meet some of the proper Kotlin people, and I realize I'm just writing somewhat strangely kind of Java instead of writing actual Kotlin.
Yeah. Well, I can write mediocre code in any language, so
The easiest language to write mediocre code in is Golang. I think Golang is made for making mediocre code.
Right. Okay. Well, that's what I'm cracking out this afternoon then. Great. So, I mean, on the front end side, where do you guys sit?
Well, this is far out of my comfort zone. We do a lot of React, I think.
Yeah.
I also heard some teams do more Vue, but I'm not allowed to do front end code. That's one global decision, actually.
Okay, so what did you do that ended up? What did you do that ended up with you being banned from writing front end code?
This even happened before I started working at NAV. I basically traveled down. I used to be a backend developer, then I turned into an angry, bitter backend developer, and going from that to a platform developer is kind of a natural transition, because then you want to solve all the problems you've had during your career.
That makes sense.
I've did some front end stuff really early, but I have no talent, and I have no. It feels like I'm almost blind because the visual part of anything I don't respond to that at all. So it's impossible for me to say if something looks good or if something's not alive. It just doesn't work. So there's no point in me doing that. And
so,
also the front end stuff is also often kind of you need to understand normal people. And I'm good at understanding developers. I'm not good at understanding normal people.
It's an interesting interpretation. That's yeah. I'll think about that whenever I meet someone who says they're front end or back end.
Yeah.
I think
this is probably why I fall more on the back end side and Sam falls more on the front end side. I think maybe Sam's better at understanding normal people than I am.
I think we've spoken about it before, though. I think with React and with Vue, there is a lot of back end developers and a lot of back end kind of logical mentalities becoming front end developers because. I know a lot of front-end developers who are terrible at the design aspect. They still need someone to come in and help with things, but there's a lot more logic, obviously, now in the front end. So, you might want to try your hand at it and see how far you get.
I saw, I think, something on Twitter, or I can't remember, but it said instead of the full-stack developer, talking about the full-stack team. And that kind of makes more sense, that you can have kind of the specialized role into where you work in a stack, but you need a team to be able to handle everything.
As long as it's JavaScript and Node,
yeah,
then you can have everyone doing everything.
Well, that was what I was going to mention, actually, because obviously the front end stuff has crept into the back end in terms of being full stack, but it is largely with things like Node. And then I think there's Ruby as well, which arguably tries to play a fine line between being front end and back end, and then Python. And I suppose with those three languages, they tend to bridge the gap, I think, between more classically front-end things, like pure JavaScript stuff, or, where we came from with things like jQuery, I suppose, as frameworks, and now React and Vue and Angular and those sort of things, versus the back-end, which has always been either hardcore JVM or .NET, as you mentioned. But where do you guys fit on? Well, actually, from a personal opinion, what do you think of those sort of languages that sit in the middle, I suppose, Node and Ruby and Python, amongst others?
I've never, I don't have that much experience because I've never really crossed the divide into front end too much in the last 10 years, but I feel that there seems to be some people who really want to use like full stack Node. But at least I've never seen that many of them, so it's not been a big thing where I worked. And Ruby, I've never worked anywhere where anyone has wanted to write hardly any Ruby, so I have no experience with that. Python feels like something. Python always seems to come in from some kind of group of people outside the main part. Now the data engineers, for instance, really want to do Python for everything.
Yeah. Well, there's a lot. It's used a lot for scripting, isn't it? And especially in the world where you start to bring in a lot of data manipulation and obviously your data engineers and machine learning side of things. Is that something that your teams are experimenting with?
Yes, we're building things around the Jupyter notebooks, which is, for me, was kind of I really struggled when I saw them at first because it feels like kind of playground programming. But when you understand,
Scratch, I think it would
understand kind of the thought processes behind it, and understand why having this showing the data in the steps is really good for like ad hoc analytical work, for instance. It makes more sense, but I still think there's a divide there between having that for kind of exploratory stuff, and then you have to translate it into proper code when you want to have something running in production for a while.
Yeah,
because then you need kind of the robustness and the monitoring and everything.
Well, also the computational speed as well. I mean, there is a massive difference in terms of. I haven't done much benchmarking recently with the JVM, but on the .NET side, those languages are so much faster. So much faster than some of these, or some of the more sort of hybrid languages or the processing languages like Node and Ruby and Python.
I really think there's going to be a lot of development in kind of the intersection between backend programming and data programming, where you have kind of because I think the brains of the data people are really interesting. They're good at looking at the data and the problems in a different way, but they haven't had the same development in the tooling that that backend development has had in the last 10 years. So nobody ever makes an application without continuous delivery, for instance, or with monitoring. And you need to get into that for the data part as well to get kind of the full value of everything that's happened in the software world for the last 5 years.
Well, I think this is where you were heading before with the full stack team idea, isn't it? I mean, I think you probably have to, well, you still have to have the depth in one of those areas, really. And you need to have a team that is made up of people who have that depth in the right areas. So as a collective team, the team has more power than a team of just generalists.
Yeah, I think having analytical power in the full stack teams is an incredible strength, because then you get those analytical mindsets into figuring out and being more data driven basically in your decisions from day to day. And that's something teams often forget, I think.
Is that something you've built into that? We talked about the interviewing process briefly. Is that something that you've built into the interviewing and hiring process as well, to make sure that you are building those full stack teams?
No, but that's actually a really good idea, to have more of the data part and also in the back end interviews, and kind of merge those more together. We still have different interview styles for front end and back ends, for instance.
Well, you heard it here first. We'll have you back then to let us know how that went. So you're talking about different interviewing processes, though. So I'm curious, because I've been through a few rounds of transformation around hiring recently. How long does it take you to find somebody, interview them, and then actually return an offer to them?
Well, we're kind of there's laws in Norway about how the government can hire, which kind of slows us down a bit. But I think we're talking weeks. I think we've gone from months to weeks. But we realized when in the current market, when you do months, you just lose everybody, because no one ever only have one offer. They have multiple offers, and they normally can't wait for too long. So we had to do it quicker.
And slimming down that coding test as well makes perfect sense, because I think again some of that stuff, I've done extensive coding tests as someone who's hiring before, and I don't think it really adds much at all. I think you probably, I don't know how it works for you guys in the government, and we'd love to learn a little bit more about that, but I think you're probably better having a longer probation period and seeing how somebody behaves. Gels into a team and starts delivering stuff. I found that to be a better measure than can somebody solve an algorithmic problem, as you mentioned before in an interview.
I really think although I'm curious to see if because I've never done the algorithmic part kind of interview, so I would be curious to see how that matches how they code normally when you don't have to balance a binary tree. Which I've never actually done professionally. No, but I think
no, I don't think anyone ever has. I mean, one of my favourite questions was to. I like to do a lot of search related questions. So I had a search question which was, if you've got a bag of 3 different coloured balls, can you sort that in a single pass, or as close to a single pass as possible, and seeing how people would go through it. And I've done it. I have one of the last places I worked. I asked the questions to the developers that we actually had on the team, and funnily enough, the only person who could actually solve it was the product manager, who so happened to be a PhD in mathematics, and he wasn't very good at coding. No. And but the developers, it was interesting to see how they thought and how that actually because they were working full stack, they were doing a similar microservices architecture to what you've got, to what Fred designed, because I'm a big fan of that stuff as well, but with .NET instead of JVM. It didn't really have any impact on how they thought about stuff and how they programmed.
We basically have 2 different coding tasks for interviews. One smaller one, which is basically connecting to one of our APIs and showing the data. Because I always find that integration code is important. That's something almost, at least backend developers, you have to do some kind of HTTP code at some point. And then, yeah. And the other part is a bit bigger, and I've actually stolen this from some kind of Guardian, the newspaper code kata thing on GitHub.
Oh, really?
It's like it's something to do with blackjack, the card game, where you kind of have this small description of an algorithm for the blackjack game. And we basically wanted to code that, and then you have to have the card and the player and the hand and the game. So normally it turns out into 4 or 5 different classes and tests and everything. And then just talking to the people about why did you choose this model instead of that, and what would happen if it did this instead of that. And also the other thing is how many people who goes far overboard in complexity, which is more interesting than the other part, I think. And
I presume that's the one that you give them a bit more time to respond to.
This is like when we see 3 or 4 hours, I think, of coding in that. And the important part then is how they talk about it, and also, for instance, how they react to constructive criticism of the code, to see if they kind of go into defense, or if they want to just say, well, this is a good opportunity for learning. Because I feel that when you work in a team, if you say this is my code, that's never going to work in a team setting. You have to kind of have our code, and then you have to understand that other people might have better ideas than you.
I think it's quite a good idea, I suppose, to pick something where it's a standard game like blackjack, where even if you don't know it intimately, you know the idea and the concept of it. Because that's very similar to the bowling game kata, which it's an Uncle Bob one, I think, isn't it, for teaching unit tests? So yeah, I think that's quite a good one to go through. But I think you're absolutely right. I tend to focus more on a design question these days, because I like, as you're saying there, I like to see how people think about things and see how they're responding to stuff, and also, given new information, how they then change their design, or you throw an additional problem at them, saying, like, okay, say this thing that we've built or we've designed as a website, maybe an e-commerce site. What are we going to do if we're all of a sudden receiving 10 times the amount of traffic? How are we going to modify it? Where are the bottlenecks going to be? And I found that to be much more effective in terms of determining whether someone thinks in the right way.
For senior people, we have somewhat like something like that as well, but that's something you just get in the interview. You're kind of giving these requirements. What boxes do you want to draw on your architecture diagram, and why? Because that's kind of shows it. I feel that's a very different skill. Basically, there's
architecture. Absolutely.
Yeah, there's not that much correlation between who does the one thing good and the other thing good.
Yeah, I think you from asking that question, you kind of know. It allows you to sort of place them in as to how senior they are. Because because it's quite a good question, because you can either go deep into the code or you can come out and be more abstract. But anyway, that's a little bit of a side story. So, whilst we're on the idea of interviewing, like, actually, one of the hard things is interviewing people remotely, because we're all remote at the moment. I presume you guys are still all remote as well.
Yes, we've been. Funnily enough, we built a new office in 2019, and 2020 was going to open in the summer of 2020. And,
timing perfect.
Hardly anyone has ever been there, but we worked almost exclusively remotely since 12th of March last year.
Wow. And so how have you managed to be able to do that remote working, especially with all of the XP type practices that I'm sure Fred brought along?
Actually, my biggest learning from all this is that pair programming is better remote than in the office. Because some of the things that, at least for me, and I think for quite a lot of people, is tiresome with pair programming comes from the physical closeness and the fact that you can't even look at something else. It feels like you're kind of disappointing your partner. but when you have it remotely and you share a screen, for instance, we mostly use Zoom for this.
Right.
It feels like you can last longer pair programming when you sit at home and you just share a screen. And also it's easy to do like mob programming, so we do quite a lot of more than 2 people together as well.
Okay, so you're actually moving up from pairs to triplets, I guess, and more.
Yeah, and sometimes, and it's probably often correlates with where we are in the problem solving process. When you're kind of early, you want more people in because then they understand the boundaries of the problem, and then it's easier to say, well, you two go do that and you two go do that, and then we meet again when you've kind of had a shared understanding of the base.
So how do you coordinate that then? So I presume you all start with a stand-up in the morning, and then where does it go from there?
Actually, another really cool pattern I've seen is that we use Zoom, and we have this what we call the lobby for the team. They have this one Zoom room, and then there's someone's responsibility to make a lot of breakout rooms every morning. And then everybody meet in the big breakout room, in the big Zoom room, and then they go into the different breakout rooms during the day and then come back for lunch. So normally they just continue where they left off the day before, or they have some kind of stand-up either. I think we've actually gone a bit, at least some teams have more like a weekly thing than a daily thing. And
right, okay.
But
they're still connecting. But they're still connecting each day to.
And they kind of have for the 3 or 4 different things they work on during the week. This is normally a bigger group that probably you would call multiple teams. So they don't. So you can probably say they have like a weekly thing altogether, and then they have almost continuous coordination in the smaller group where they do loads of mob programming, for instance. And you don't really need a stand-up to discuss what you're all going to do together after the stand-up. Then you can just start doing it, and then you split out into pairs when you need to.
That's interesting. So is that that's an interesting evolution of the agile way of working then? So is that something else that's come from Mr. George, or is that something that you guys have worked towards yourselves?
This actually has come more naturally after we've gone full remote. I think we have more adaptation of pair and mob programming remote than we did before. We did pair programming, but this was more pure pair programming when Fred was there. When he kind of said, well, basically we had we rotated pairs every day, and at least the teams he were in. But I think we kind of gone for a more different model after that, and I've seen the funny thing is this model has spread into multiple teams where they kind of do it the same way with the Zoom rooms and the mob and pair programming.
And did that evolve naturally, or was that a suggestion across the organization?
Quite natural. I think we had a few people saying, well, we did this and this is smart, and then some other teams tried it. The only thing I'm worried about is this kind of place, the Zoom licensing model. It doesn't. This is a very cheap way of using Zoom, so I'm assuming someone is going to change this model at some point. Because then we basically have 10, 20 people using one license because they're all in one Zoom room with breakout rooms.
Oh, we won't tell Zoom if you don't. But I mean, I'm sure someone else will come along with a cheaper model that will work for this. Because if this is a, I think maybe we are due a different way of working. As agile as defined is 20 years old. And actually, there's plenty of practices, as we discussed, I think, with Fred, didn't we, Sam? Leading into that, there was plenty of agile-like practices leading in. But obviously, this is a new world we're in now, so we're maybe due a different iteration in the way that we work together in software. So the one thing that stands out to me, though, is if you're this flexible in your working, and as long as the work is getting done, that's great. But how do you measure the progress on that? And then how does that get reported back?
Well, this is one of the big problems, of course, because I've always found measuring progress is difficult in software development. It's difficult to say what you measure against. Because normally you want to measure against a plan someone made beforehand, but that plan stopped being sensible the day you started coding normally. And then you can reiterate on the plan, but then you're just reiterating based on the knowledge you get whilst coding. But we have this external pressure, might be too big a word, but you have this external thing of the governmental ways and the processes for, we get all this money and they need to make sure that we're spending it wisely. And we've had loads of, trouble discussions on figuring out how to do the continuous improvement and the product model in a world where we also have external requirements on reporting progress. And it feels like sometimes we haven't found a really good solution, I would say. I really like this. There's this quote from Brandolini, an Italian software, the guy behind Event Storming. He says that creating software is a learning exercise, and the functioning code is just a side effect. And if you really but if you really take that into heart, you think, what does that mean for how you work? Because then you should really start to measure the learning, not the code, because the learning is the difficult part, and it's incredibly difficult to give an external measure on how much have we learned about this domain. It's much easier to say, well, we managed to handle 50% of all the applications, for instance. But that might be the easy part, or that might be all the difficult parts, and you've done all the important learning. So I think one of the things is you need to reduce the distance between the people who care about the progress and the team. And basically try to get, if the team are responsible, then at least in theory, you don't need anything outside the team caring, because the team is actually the responsible party here. But of course, this is somewhat utopian and not easy to implement.
Well, yeah, and I think it's also very difficult because if you've got commercial requirements as well, if this thing needs to be shipped by a certain date, or say you're working with a client who's expecting a delivery on a certain date, then you're always going to have to return to estimates. And I totally agree with you in terms of it is a learning activity. The plans are off as soon as you start coding. I think that's where you kind of still have to be good at estimating or refining those estimates, or giving enough of a window, I suppose, that we think we can do it within this time, and the closer we get to the finish, the more accurate we'll be able to tell you when it's going to finish.
And you kind of have to do this from the start, saying this is an estimate, but read all these books about how estimates doesn't work before you look at them again.
Well, half the problem is explaining what an estimate is, I suppose, isn't it, to the business? And it is an estimate. It is not a guarantee.
And it's normally a bad, and that doesn't mean you can just say the earliest date is when the team has promised to deliver, which is kind of what it feels like people hear all the time. And also, I think it's there's still, this is probably the most difficult thing we do right now, to figure out how to do agile product development in a world where we have external parties that doesn't really understand what that means yet, but they still have these processes they need to fulfill.
Absolutely. I think that's probably the next challenge, but not one that we're probably going to answer today. So I think we're probably coming to the end now, because I think we've used up more than enough of your time. So thank you very much for spending the time to talk with us today. It's been a really interesting conversation, and hopefully at some point when travel restrictions are lifted, we might actually be able to see each other in person at some point, which would be nice.
Thanks for having me as well.
Well, thank you very much for joining us.